Now we'll take a look at an example of a reciprocal function as far as graphing it is concerned. If we look at this, it says graph f of x equals 8 over x. Now, very simply, you could do a t-chart for these, and you can see how in step 1 the t-chart is created, a set of x and y values, and then in step 2 how we plot those values and create this kind of smooth curve. Now, generally speaking, you should just really kind of practice sketching these and understanding what the various a, h, and k values do to the reciprocal function. I'm not going to put a lot of emphasis on the detailed points and the exact graphs. Again, a lot of this will be sketching to understand the generic nature of these curves, and then also just being able to identify them or match them on Math Excel or on a test. So you can see very simply how this plays out. Now it says identify the x and y intercepts and the asymptotes of the graph, and it wants us to state the domain and range. Well, since the x and the y axis technically are the asymptotes, it actually has no intercepts there, so it never touches either one of them. In this case, the domain is a set of all real numbers except x can't equal to 0, and that kind of takes us back to what you saw in our function operations an earlier unit. So, and again, the range is similar, all real numbers except 0. So if you look at this next problem, go ahead and do this next problem. You can do a t-chart for both of them and try to do a smooth curve. I'm going to just go ahead and do this on the calculator so that you can at least get a visual of what they should look like in comparison to each other. Alright, so if we take a look at this, we have in the blue f of x equals 2 over x, and you can see how much closer that kind of hugs the x and the y axis all the way down to the origin, and how the 12 is a much bigger number, so the a value is much bigger, so it kind of creates a kind of a curve that's a little bit farther away from the origin, if you will, and so that would continue to get farther and farther away. So if you did 50 over x or 100 over x, you could see the effect of what that does. So this just gives us a good look at what this graph does. Now, here's something that's very important. The two parts, so if we're just talking about 2 over x, if we look at the two blue parts, those are not two separate graphs there. Those are the graph of the same function, so they're together. They're not two separate parts. Well, you see here in the notes, we call those two separate parts branches of the reciprocal function. Okay, and so you got to understand that they go together. You can't have just one or the other. They actually go together. Now, you can stretch and compress or translate these branches similar to the way we could do other functions. So if you look here, we have the a, the h, and the k involved in the reciprocal function and how it affects each of those different branches of the reciprocal function. So if you come back in the next video, we'll take a look at the two sample problems on the last page of the notes.